are going to talk about our next type of transformation, which is a reflection. So remember, a reflection is like a flip. So I said we're going to need a line, and then we're going to take our object and we're going to flip it over that line. It's like a mirror. Okay, so when we do this, what we're going to need is our object, whether it's a point or whether it's a figure like a triangle, and we're going to mirror that object over the line. When we do that, the points should preserve a distance along a perpendicular line. Now remember, perpendicular, we learned about perpendicular slopes in the last unit and learned that those slopes are opposite and reciprocal. So that's going to be kind of an important idea for us as we think about how to flip over diagonal lines, angled lines. So let's look at some examples. So let's see, get the screen a little bit bigger, maybe not. Maybe we'll just let it be the size that it is. Okay, so we are going to be working on a graph, so I'll bring a graph up. All right, so you're going to have, we'll start with just a point. And let's say I'll put the point right here. And let's say first thing I want to do is we are going to reflect over, let's say, the x-axis. So we're going to reflect it over the x-axis. Okay, well, I have to think about which one is the x-axis. Remember, our x-axis is this one. So this is our line of reflection. The x-axis is our line of reflection. So as we think about that line of reflection, what we want to do is think about connecting our point to that line, perpendicular, and then going that same perpendicular distance onto the other side of that line. So how many boxes? 1, 2, 3 boxes. So I'm going to go 1, 2, 3 boxes on the other side, and there I find my image. So remember, we call the first one the pre-image, and then after we've done the transformation, we call that the image. So there's our image. Okay? So there's an example. Let's look at another example. I'll just put up a new set of axes so we don't have to use the same one. And let's say that this time the problem says reflect the point, let's say, -1, 5 over the y-axis. Okay, reflect the point -1, 5 over the y-axis. Well, where is the point -1, 5? All right, -1, that's our x, and then 5 is y, so back 1, 1, 2, 3, 4, 5. There's my point, -1, 5. Now this time I want to reflect it over the y-axis. So the y-axis is now my mirror line, and I want to think about connecting that point to the mirror line perpendicular. How far is it? It's 1 box away. So I'm going to go 1 box away over on the other side, and there I find my image. Where is that image? It's at, well, now x is +1 and y is still 5. So those would be the coordinates of that image. Okay? So when we're reflecting over a horizontal or a vertical line, we connect then and maintain that same distance away. We would do the same thing if we were working with a whole shape. So here we just had some points. Let's say that we had a whole figure like a triangle. Ooh, a little curvy on my axis there. Let's say that I have that on there. Okay. There's my figure, and I want to reflect this over, let's say, the x-axis. I want to reflect this over my x-axis. Look at my x-axis here. All right, that's the line that I am going to flip this shape over. We can think about a visual idea of reflecting as kind of like butterfly wings. Like if I fold this closed like a book, then I should have a perfect matching butterfly wing down on the bottom of this when I fold over that x-axis. So to do that, I want to take each point. I want to go, okay, that's 2 spots away. Go 2 spots away. And there I find the image of that point. Okay, now do it for the next point. Go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there I find that point. Okay. Take this one, go 1, 2, 3, 4. Go 1, 2, 3, 4. It has to be the same number of boxes on each side, so we're maintaining that distance. And then when I connect those dots, we get the perfect matching butterfly wing on the other side. Okay. When you look at two shapes, and let's say we wanted to find a line of reflection. Let's say the two shapes are already there, and we want to find a line of reflection. Just erase the whole thing. Okay. Whoops. Uh-oh. See if I can make it come back. Oh, but then, all right. Well, back, technology. Okay, so let's say we have to make this maybe a little bit easier, just because I'm making it up on the spot. And let's say we have all right, so let's say we have this picture, and it says to find the line of reflection. Okay, so I want to think about, well, where would I fold this paper closed? Would I fold it closed this way? Would I fold it closed this way? How am I going to fold this closed so that when I do so, those two images completely and perfectly match? To do that, you could take any of kind of what I would call like the partner points and look at how far apart are they from each other, and we need to go middle, like midpoint. We need to cut that distance in half. So what's exactly in the middle of those 2 points? Well, that point is exactly in the middle of those 2 points. Okay, well that gives us 1 point. Well, we need another point. You need 2 points to make a line. So if I, let's say, take these two, well, let's see, 1, 2, 3, 4 boxes apart. So cut that in half would be 1, 2 boxes. There we go. So where is this line of reflection? There's my line of reflection. Okay, so we could place that line of reflection into the right spot, either horizontally or vertically. The last type of problem I want to look at with you is the trickiest, and it's definitely going to be the trickiest for me to draw. Welcome back. Okay, so I actually just ended up cutting the video out so I could do these drawings without you guys staring at me, and now we're ready to go. So now I have a couple of examples. So on these ones, our line of reflection is diagonal. It's not just the x-axis or y-axis or even a horizontal or vertical line. So finding a diagonal line of reflection is a little bit trickier. So to find a diagonal line of reflection, what we're going to do is look at that top example first. I want to find 2 of the partner points. So a point's pre-image and image, so like A and A prime. So I'm going to look at point A and A prime. And I want to look at how do I get from point A to A prime, so kind of like slope. Well, it's a fall of 2 and a run of 2. Well, if I'm supposed to go exactly in the middle of those 2 points, so thinking about like midpoint, I want to think about, well, instead of falling down 2 and running over 2, I want to take the middle of that. So I am going to fall down 1 and run over 1. And that point should be on my line of reflection, exactly in the middle of A and A prime. Then I can do that again for either point B or point C. It doesn't matter which. Point C's are kind of closer together, so I'm going to choose to do those, but you could do point B's as well. So for point C's, as I connect those, fall 2, run over 2, fall 2, run 2. I'm going to cut that in half. So instead of falling 2 and running 2, I'm going to fall 1 and run 1. And that would give me that midpoint between those point C's. Those 2 green dots should then be on my line of reflection. So then I could draw in that line of reflection and think about folding my book now on that diagonal line and having those 2 triangles meet up. Okay. I have a more complicated one underneath it. So I drew them in 2 different colors so that we could see them. So we've got the regular ABC triangle there in blue, and then we have the prime triangle in red. Now what I want to do is pick any 2 partner points and make that connection, like the rise over run, the slope for them. So it doesn't matter which 2 I start with. I'm going to start with point B. Doesn't matter which ones. I'm going to start with point B. I don't know, just because they're kind of out there by themselves a little bit, not as much in the clutter. So as I look at point B, to get from B prime to B, I would go over 2 and up 1, 2, 3, 4, 5, 6. Well, if I want to cut that down in half, instead of going over 2, I'm just going to go over 1. And instead of going up 6, I'm going to go up 1, 2, 3. That point should be on my line of reflection. Now I need a second point, so I could do it for any of the points that I want, A, B, or C. I already done B. I could do A or I could do C. I'm going to choose C just because, again, it's kind of off over by itself a little bit more than A is kind of right in the middle of everything. So might be a little bit more clear to draw over by point C. So point C, oh boy, how far do I have to go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes up. I have to go 12 boxes up. So if I'm cutting that in half, I'm just going to go up 1, 2, 3, 4, 5, 6 boxes. Okay, so that in green there puts me right at the axis, if you can see the difference in those colors. All right, so that's my halfway up. Now over. Go over 1, 2, 3, 4 to get to point C. But if I'm cutting this in half to find a midpoint, I'm only going to go over 2. So there is the midpoint between C and C prime. And if I connect those 2 dots that I've made, I should then find my line of reflection. One thing to notice about the line of reflection, if this was graphed absolutely perfectly, it should go through the places where those lines are intersecting each other. So you can see kind of 2 X's that are being made with the red and the blue lines. It looks like it hits the one pretty good. It's a little bit off on the other one, but that's just my drawing. It should go right through those when they overlap. Okay. So you'll have several different kinds of problems to look at with reflections, either plotting the reflection or finding the line of reflection, horizontal or vertical or diagonal. So let me know what questions you have as you're working through these, and I'm happy to help. See you again soon.